Hi, welcome to the statics tutorials. So this is our third video on moments caused by couples. And so in this system we have a couple moment here where we have 921 newtons, and then we have the 921 newtons going in the opposite direction. We have just a regular old force, 500 newtons, so we can see how we deal with those when they're mixed in with couple moments. And then we have a couple moment here of 747 newton meters that's represented just as a counterclockwise or clockwise rotation that's acting at a certain point. And couple moments can be shown either way, either this way or this way. Outside of kind of the introduction to couple moments, most of the time in the rest of the course you're going to see them just as a rotation and being located at a certain point like this. So let's look at both of these. So let's say that we want to calculate the moment about A. Let's start with the easiest one, which is this one where we just have the magnitude of the couple moment and the direction shown. We need to just figure out, is this a positive or a negative couple moment? So we'll use the right hand rule. Looks like that this is going to be a positive moment. We can also take a look at this and say, hey, this curved arrow is going counterclockwise, and counterclockwise is positive. So even though we're looking at A over here, anytime we're doing a moment anywhere on or off the body, we're going to just include this 747 newton meters as a positive contribution to the moments at that point. So we just stick it in here, positive 747 newton meters. Now let's deal with the next easiest thing, which is just our plain old 500 newton force. So we have a force in the x direction. We need the perpendicular distance back to this point A. So if it's in the x, our perpendicular distance is going to be in the y direction. So this is going to be our 500 newtons times our 0.3 meters here. We need to figure out direction. Looks like at A, this would be a negative contribution to the moment at A from that 500 newtons. So negative 500 newtons times 0.3. And then last, let's deal with this couple moment that we have here, the 921 newtons. So with this one, we need to either calculate a perpendicular distance between the two forces, and that looks like kind of a pain, or we can do what we did with the last video and separate these out into a force in x and a force in y, and a force in x and a force in y. We can see that the forces in x really go through each other, so there's no y separation, so we don't need to include those in the calculation. And then the force in y would just be the force then times the distance between these. So the whole thing is 0.8. This is 0.2. The difference of that would give us 0.6. That would be our x distance. So our y component is going to be 921 newtons sine of 60 degrees times that 0.6. We need to figure out a direction. Looks like the y components are going to be a negative or clockwise moment. So we'll put a negative sign in front of that. And we add it all up and we get 118 newton meters. Thanks for watching.